Hello, my little triglets. How are you all doing? Welcome to Trig by video. Today we're going to talk about section 3.1. Section 3.1 is a fairly easy section. There are a few little vocabulary things we need to talk about. When we talk about an angle, it has an initial side and a terminal side. Initial side for our purposes is always going to be on the positive x-axis. The terminal side is just where the angle ends. So if we have a little xy grid here, the start of the angle is always going to be here, and then the angle will open up, and this would be the terminal side. And this always is the initial side. And then the angle inside we call theta. So that's a symbol, a Greek symbol, circle with a line through it. We have counterclockwise angles and we have clockwise angles. Counterclockwise is against the way of the clock, which would be that way, and that's a positive direction. If I start on my grid, I go this way, that's a positive angle. Clockwise is this way, and it would be considered a negative angle. So this would be 90, this would be negative 90. So you have to just pay attention if they don't say anything about clockwise or counterclockwise, it's always going to be considered a positive angle. So if I have 3/4 of a rotation, and we'll say counterclockwise, 3/4 of the way around would be to there, so that'd be 270 degrees. If I say half a rotation clockwise, that would be this way, and we'd say negative 180 degrees. What if I had 2 1/4 rotation counterclockwise? So 2 1/4, if you go all the way around once, it's 360. So I could say 2 1/4 times 360 to get that total angle. And if you do that, you get 810 degrees. Okay, so if you want, if it's something over one full trip around, just multiply by 360. All right, let's say you have a hand of a clock and it rotates once every 12 hours. So one rotation is equal to 12 hours. How many degrees is it for 9 hours? Well, 9 out of 12 would be 3/4, and 3/4 of the way around, we already said in the previous problem, was 270. What about 18 hours? Well, you can do the same thing, 18 out of 12. Or you could even just multiply this by 2, knowing that it's double that. So either way, it's 540. So 18/12 you can reduce to 3/2, and then multiply that by 360. That get you 540 as well. What about 4 days? 4 days, actually, if every 12 hours, it rotates twice in 4 days. So it's really 8 rotations. So 8 times 360 would give you 2,880 degrees. So no matter how many rotations it is, you're just going to multiply by 360 every time. All right, in the clock scenario, we have hours, minutes, and seconds. When we are talking about the circle, it's degrees, minutes, seconds. So when you see those surveyors out on the road looking through their little transits, they're measuring everything in degrees, minutes, and seconds. If you think about a circle, it has 360 degrees. So if I could draw 1 degree, it'd be very small. Well, a minute is 1/60th of a degree. equals a minute. So if you think about taking that little sliver there and dividing it into 60 pieces, one of those is a minute. And if you take one of those 60 pieces and divide it by 60, 1/60th of a minute is a second. So that would make 1/3600th of a degree is equal to a second. So it's a very, very, very tiny slice is a second. And you really have to, when you're building roads or skyscrapers, you have to get it down to the very minute second in order that, so your road isn't crooked a mile down the road, or your building isn't slanted once you get to the 30th floor. So what we're going to do with this idea is we are going to convert degrees. Let's go back here. So I got 36 degrees, 50 minutes, and 10 seconds. So this is minutes, this is seconds. So they use those symbols. And I want to change that to decimals, because when you try to work on calculators, it doesn't work very well in this form, so we're going to change it into decimals. And the way you do that is the 36 just stays the way it is. Because you need 60 minutes, we have 50 out of 60 of them. And you have 10 out of 36 hundredths of a degree. So we're going to change all those into decimals, add them up, and you get 36.836 degrees. So you're just dividing by 60, then you're dividing by 3600 to get them. Now going the other way, if I have 50.525 degrees and I want to change it to degrees, minutes, seconds, I have to kind of reverse the process. So we know that it's 50 full degrees, and we have this decimal portion. So you take your 0.525 and multiply it by 60, because up here we divided by 60, so down here we have to multiply to get back. When you do that, you get 31.5 minutes. So I have 31 full minutes, so I put that over here. But then I have 0.5 or half a minute. So I take that 0.5 and multiply it by 60 again. Now it's not 3600 because I've already multiplied by 60 once, so multiplying by 60 again makes the 3600. So I take 0.5 times 60 and that gives me 30 seconds. So then that adds on here. So that would be your conversion. All right. The last thing I want to talk about is something called co-terminal. Just like co-captains, terminal means the end. Co means, you're doing the same job, but you're going to have a different name. Co-captains do the same job, but they have a different name. So coterminal means they are angles with different measures, but land in the same spot. Okay, now how can that be? Let's take a look here. Let's say I go up here to 90 degrees. Okay, that's an angle. Well, what if I kept going and came all the way back around? Well, I just added another trip around, so I added 100 or 360 degrees to 90. So my other angle is 450, so I could also call this angle 450 degrees. I could go in the other direction, 360, and from here, that way is negative 270. So negative 270 would be another name for that angle. If you're starting here on the x-axis and going this way, that's 3/4 of the way, which is 270. So 90, 450, and 270 are all the same spot, but they all have different names. Now the simplest way to get a coterminal angle at any time is either add or subtract 360 degrees. That's as simple as it gets. So if I give you a 50-degree angle and I say give me a coterminal, you add 360. So 410 would be another one. Or you could take 50 minus 360. So negative 310 would also be a coterminal. So it's as simple as that. Don't make it any more difficult than that. Coterminal means add or subtract 360. All right, well, I think that's enough for your first video. I hope you enjoyed it. And just remember, Trig is love. If you love Trig, Trig will love you back. Have a good day.